Hello everyone, and welcome to another Day 1 and Beyond hands-on lab session. Today's session, we'll be working through Protect Your Data with Oracle Active Data Guard Live Labs. My name is Hannah Rockshaw, I'm a cloud engineer here at Oracle, and I'm so happy you could join us. So, without further ado, let's go ahead and get started. Here we have our agenda slide on what we'll be covering today. We'll be covering the first 5 labs, starting with Lab 1, Connect to the Database, Lab 2, Perform a switchover, Lab 3, Perform a failover, Lab 4, Enable Active Data Guard DML Redirection, and wrapping it up with Lab 5, Automatic Block Media Recovery. Now, before we dive into the hands-on, I wanted to do an Active Data Guard overview on what we'll be doing in the live labs. So starting with an architecture overview, Oracle Active Data Guard ensures high availability, data protection, and disaster recovery for your enterprise data. It can survive disasters and data corruption while simultaneously creating, maintaining, and managing one or more synchronized standby databases. So here we have in our primary region, our primary database with Active Data Guard enabled. In a separate availability domain, we have a local standby. And then in our secondary region, we have our remote standby. So what is this useful for? The first is planned maintenance. This is what we'll be covering in Lab 2 when we show how to perform a switchover. A switchover is a role reversal between the primary database and one of its standby databases, and it guarantees no data loss. During a switchover, the primary database transitions to a standby role, and the standby database transitions to the primary role. This can be good for any sort of cascading updates or planned maintenance for your databases. Now, what if the downtime is unexpected? In Lab 3, we're going to go ahead and simulate a failover. A failover is a role transition in which one of the standby databases is transitioned to the primary role after the primary database, or in all instances of the Oracle RAC database, fail or become unreachable. Additionally, with Fast Start Failover, this allows the Oracle Data Guard broker to automatically fail over to a standby database without the need for any human intervention. Now, are there any other uses for my standby databases? Yes, and that is a fantastic rhetorical question. You can offload more than read-only workloads to your standby database through Oracle DML Redirection. This feature lets applications manipulate data from the standby database, which will free up important resources on your primary database. It increases the standby database usage and ultimately your return on investment. Now, under the hood, Oracle DML Redirection redirects the DML to the primary database. The transaction appears to have been executed on the standby, but are executed on the primary database. And this is done in 5 steps. The first, we have a session connected to the standby database that issues a DML statement. From there, the DML is redirected to the primary database using a database link transparently created by DML redirection. Then the DML is applied to the primary database. The change is then streamed back to the standby database with the normal data guard replication. And then the result of the DML is visible in the privacy of the transaction that was started by the session. And once that session commits the transaction, the data will be visible to other sessions on primary and standby databases. What if my data gets corrupted? Can Active Data Guard help on that? Well, have no fear, automatic block media recovery is here. So if corrupt data blocks are encountered when a database is accessed, they can be automatically replaced with uncorrupted copies of those blocks. So let's say, for example, we find corrupted blocks encountered on our primary database. The primary will automatically search for good copies of those blocks on a standby, and if they're found, have them shipped back to the primary. The reverse is true as well. If the standby has any corrupt data blocks, then the standby will automatically initiate communication with the primary and request uncorrupted copies of these blocks. This provides automatic and user-transparent recovery of your corrupted database blocks from your standby database. Now that we're armed with knowledge, let's go ahead and apply those to our hands-on lab. We're going to start with Lab 1, connect to the database. So once you're signed in to the OCI Cloud Console, the top left, we're going to go to Navigation menu, Oracle Database, and then in the bottom left, we have Oracle Base Database Service. If it says you couldn't load data, that means that you're not in the correct compartment. I can see here that I'm in the root compartment instead of my own. So I'm going to go ahead and select it, select Live Labs, and then select my compartment. So here we have our two database systems that have been created for us. The system that is prefixed with ADG HOL D1 is our primary database, and the one that's prefixed the same but with the number 2 would be our secondary database. So clicking on our first, which is also our primary, here we're on the DB Systems Information page. This is where you'll find general information, networking, any sort of versioning about your database system. What we're interested specifically in is nodes. So here we have our public IP address. I'm going to go ahead and copy that and then launch the Cloud Shell in the top right. We're going to go ahead and close out of that, say no to the tutorial. And then what we'll need to do, because we're using the Live Lab sandbox, is upload our private key. We provided our public key when we were provisioning, so now we need to supply the private key in order to connect to the DB server. So in order to do that, I'm going to go to the little gear and then upload. And I have mine on hand, so I'm just going to go ahead and drag and drop it. You are more than welcome to select it from your computer. Once that's completed, I'm going to go ahead and hide that. And then I'll need to change the permission of the private key in order to be able to use it. Okay, now that the permissions are changed, I'm going to go ahead and SSH in using that IP address that we copied. So here we can see that we are successfully logged into our primary database, OPC, at ADG HOL AD1. Just to double confirm, I'm going to go ahead and change into the Oracle role and then connect to the database as sysdba. Now I'm going to run this query that will select the name, the database unique name, and the role from the database file. And so here we can see database role, we are in fact on our primary. Now in a separate tab, we're going to go ahead and create our connection to our standby. So I'm going to duplicate, go ahead and exit that, go back to DB Systems, nodes again, and then copy awesome. So now I'm going to do the same SSH. And then change into the Oracle user. And run the same query. So here we can see that this is our physical standby database. So that concludes Lab 1. For Lab 2, we're going to go ahead and perform a switchover. And we're going to do that from the OCI console itself. So switching back to our primary, I'm going to minimize this, go to Databases, select our database, and then the third tab here is DataGuard Associations. So here we can see our peer database in the standby role, as well as the protection mode, the transport type, the lag, and the DataGuard type. Selecting the 3 dots, and then switch over, It's going to warn that this is going to take a little bit of downtime, so it will require you to put in your database admin password because of that. So pasting it in and then hitting OK. We can see here that the database is now updating. So now we can see that our database is available and that our PeerDB system, which again ends in 82, has the primary role now. Just to verify this, I'm going to again select the name, database unique name, and database role from the database. You can see here though that the connection has been lost. So what we'll need to do is reconnect as sysdba and then rerun that command. So here we can see previously we're the primary role and now we are in the physical standby role. I'm going to do the same thing. I did it in one query or one line instead of doing it separately. But here we can see we were the physical standby and now we are the primary database. So this means that our switchover was successful in performing a very graceful role transition. For our third lab, we're going to go ahead and perform a failover. So going back to our database system that ends in 82. So as I said previously, you can see that it's been updated. So what we can do now, instead of switchover, it says failover. Go ahead and select that. Re-enter your database admin password, because again, this will cause a little bit of downtime. Go ahead and minimize that while we wait. Once that database is available again, you can see here that our peer system has the role disabled standby. A failover means that the old primary, so in this case, the one that ends in 82, will be disabled. In order to use it as the standby again, we'll need to reinstate it. Doing so is rather simple, going to the three dots and selecting reinstate, entering our database admin password, and then waiting again for it to update. Now that our system is available again, we can see that our database ending in 82 now has peer role as standby. Of course, we can also run it in the command line, ask our database. So I'm going to go ahead and run that query. So here we can see that our database role is now primary. If I run it again here, need to reconnect. We can see that this is now the physical standby. Previously, it had the primary role. That concludes lab 3, so we're going to go ahead and jump into lab 4 that allows us to enable Active Data Guard DML redirection. DML redirection is specifically for user tables, so it is not possible to use it using the sys user. If you try and run a DML statement, it'll go ahead and fail. So what we'll need to do is create a common user in the database in order to learn more about this feature. I'm going to go back to my primary. And what I'm going to do is create user, HOL user, identified by password in all of the PDBs. Then I'm going to grant, and then I'm just going to verify that the user has been created. So automatic redirection for DML operations can be configured at either the system level or the session level. For this example, we're going to go ahead and do it on the database level. So in order to do so, we'll have to set the parameter on both the primary and the standby database. So on the primary, and then on our standby, and then we're going to go ahead and connect to that common user we created. So as we're connected to our new user, we're going to go ahead and create a table only on our primary. And then on our secondary or our standby here, we're going to go ahead and describe the table that we just created. So again, we created that table on the primary, and here we can see it exists on our secondary. For the redirection, We're going to go ahead and insert into our table on our standby. So we can see one row has been created. And then we'll go ahead and commit. And then if we query that table, there we can see ID1 means that the data has been successfully inputted into our SQL table. Now for our final lab, lab 5, automatic block media recovery, we're going to need to set up our environment first. So I'm going to go ahead and exit, and I'm going to go ahead and download 3 scripts as the Oracle user that are provided in the live lab. Doing a list, I can see that they have been downloaded. And then before I proceed, I'm going to go ahead and duplicate this tab and log back in, and then go back to my original tab and tail the alert log. With that second tab of the primary, I'm going to go ahead and log into the primary database and then change to the container database titled mypdb. Inside of that, I'm going to run one of the scripts. And what this script does is it creates a table space, adds a table in it, and then inserts a row. An important thing that we'll need to note is that it'll return the row ID. This is needed in the next few steps. Go ahead and jot that down. In the same session, we're going to go ahead and execute the second script, and it's going to ask for that block ID and enter that number. Now we have our corrupt data file, but our database is not yet aware of it. So what we'll need to do in order to make it aware is to access that table is the database alert log that we have in the first tab. So I'm going to go ahead and pull this out. Now we're going to run our third and final script. Now there I had to flush the cache. This is because this demo database is not active, so it is necessary to flush it before we access the table. That way the data is read from the disk, and since this data is corrupt, Active Data Guard will repair the corrupt block before returning the query results. So looking at our database log file, we can see that the corrupted block has not generated any error for that user session. We can see in the alert log that automatic block media recovery service is active, as well as automatic block media recovery was successful. So with that, we're going to close out Lab 5, automatic block media recovery, as we've seen it in action ourselves. So that concludes our demonstration. If you're interested in learning more, we have a number of different options, including courses, hands-on experience, more details, live labs, and Oracle Learning YouTube videos. If you're interested in any training for your organization, we have Oracle Cloud Personalized Training in 3 different flavors, as well as our developer experience. Thank you again for joining me, and if you have any additional questions, please email us at personal-trainers_us@oracle.com.